I like music. How much? This much. Now what about chemistry? This much. So how could you possibly combine them? Buckle up and get ready to find out. Music is often composed of intervals, or two notes any distance apart. These intervals are either played together or separate. For the sake of this video, let's focus on the most common one, the perfect fifth. It consists of a root, which is any arbitrary note, and the one 5 notes above it when following the natural major scale. It is called perfect because of how consonant the two frequencies are with each other when played simultaneously. The other two types of fifth intervals are called diminished, where the fifth is lowered by one semitone, and augmented, where the fifth is raised up by one semitone. We'll come back to that later. 17th century Russian composer and music theorist Nikolai Daletsky took this concept to another level by creating the circle of fifths as you see here, with each note being a fifth away from the previous one. This model is an extremely useful tool for understanding the ins and outs of why certain aspects of music theory are the way they are. You might be thinking, what does any of this have to do with organic chemistry? Well, it doesn't, but it does if you force it. Take the 6-carbon aromatic we all know and love, benzene. Now for fun, overlap it with the circle of fifths, two drastically unrelated concepts, but prepare to be amazed. Because of how there are 12 different notes on the circle, the 6 carbons can line up on 6 of those 12. Those 6 notes create what is called a whole tone scale, with each note in the scale being 2 semitones or a whole tone apart. Whether played in succession or in unison, it creates the unsettling feeling of the unknown. This type of sound is often associated with the cheesy audio of a flashback in classic movies or when a character is pondering in confusion. It portrays a sense of floating in space because it lacks the regular semitones of a major scale that are responsible for the feeling of home, essentially removing the aspects of stability through the lack of predictability. Now, if you rotate the entire benzene molecule 30 degrees, each carbon touches notes that belong to the second of the 2 whole tone scales. We say there are only 2 different whole tone scales. The first variation contains C, D, E, F sharp, A flat, and B flat, while the second variation contains D flat, E flat, F, G, A, and B. So you can see how starting on any note places you in one of the 2 scales, no matter the starting position. Now to spice things up even more, consider the note that corresponds to the middle of the double bonds. There are 3 as seen here, C, E, and A flat. These notes create the outline of what's called an augmented triad. Sound familiar? It's because the C and the A flat are an augmented fifth interval away. The E in between is the major third interval, common to all major triads. This pattern can be seen with each of the 2 orientations of benzene and each of their own set of contributing resonance structures. This creates 4 different variations of augmented chords. Similar to how there are only 2 whole tone scales, by the same logic, there are only 4 versions of these augmented chords. This type of chord offers a similar sound to that of the whole tone scale. Lost, disconcerting, question with no answer, deprived of normality. Probably how you are listening to this right now. So what did any of this accomplish? Well, not much. Could I say that this relationship is symbolic of how learning organic chemistry for the first time leaves you with unanswered questions and feeling deprived of normality? I could. Could I say that the whole tone and augmented music theory is similar to organic chemistry in a way where they both seem complex on the surface, but are rather intuitive when you put in the time to learn? I could. However, I feel the main idea behind this video is that when you are more restricted, you are forced to be more creative. If you are given no limitations and gifted with every resource in the world, it's very easy to feel overwhelmed and not think outside the box. Being confined to bridging the gap between chemistry and my preferred method of expression, music, prompted a lot of what-if questions and helped squeeze out every ounce of creativity that I had. Even though nothing tangible was achieved by making this specific comparison, it doesn't mean that other comparisons won't. This brought forth the importance of curiosity and its value to the progression of the human race. Thanks for watching.